It's not in there yet. Alright, put away your phones, eyes up front. These are notes, area, and perimeter of irregular polygons and composite figures. A composite figure is made up of 2 or more regular polygons. A regular polygon is something on the formula sheet. So a regular polygon is like a triangle, a square, a rectangle, a trapezoid, a parallelogram. Things that you have specific formulas for. Since these are made up of 2 or more regular polygons, we will use 2 or more formulas to find the area. So we can figure out the area and perimeter of irregular polygons and composite shapes by breaking them up into shapes we are familiar with. So this is a funky looking shape, but we can break it up into 2 rectangles because we know how to find the area of a rectangle, I hope.
Wait, what?
So by drawing a line right here, I can identify one rectangle that has a length of 2 and a width of 3, and then I can identify a second rectangle that has a length of 4 and a width of 6. And when I find the area of each individual rectangle and add them together, that is what the whole shape is created by. So this little rectangle has an area of 2 times 3, which is 6. So I like to write things down inside the shape so I know I've covered all of them. So I'm going to write down that this area is 6 meters squared. This rectangle, same formula, length times width, 4 times 6, which is 24. So I have a big rectangle with an area of 24, a little rectangle with an area of 6. This whole shape is these 2 rectangles added together. 6 plus 24 is 30. Make sure you put your units. It is meters squared. Okay. We also have to find the perimeter. Remember, the perimeter is the length of the outside. All you do is add up all the sides. So, if this part is 3, this part is also 3. Oops. If this part is 4, this part is also 4, which makes this whole side 7. A short side of 3, a short side of 4 makes the whole length 7. So 3, 2, 7, 6, 4. I'm also missing this side right here. If this side is 2, this little part is also 2, which means the rest of that is 4. So this part's 4, which means this part is 4. So now that we know the length of all the sides, we add them up.
26.
So 4, I'm going to check it off, plus 4, check it off, plus this whole side is 6, check it off, this whole side is 7, check it off, plus 2, plus 3 equals 26. Your units are meters because it is a length, like on a ruler. Measure in inches or meters or yards.
There's no square. No.
There's no squared because it is like you're taking a ruler or a measuring tape or a yardstick and lining it up. The units on that stick will be like no square, no cube, no nothing.
I see a triangle and a rectangle.
Okay, down below, Elias said he sees a triangle and a rectangle.
It's a pointer. What do you want?
So in this area, there's a triangle and a rectangle. This rectangle, the area is the length times the width. So this part is 12 times this part, which is 2. And then we have our triangle here. Remember, on a triangle, your base and your height are always perpendicular. That means they make a right angle. If you take your base right here, or one of these sides do not make a right angle. They're kind of curved right there, or slanted. So your base or height is not 10. Do not use that in your area formula. This is our base right here. What is it? 4. 1 plus 2 plus 1 is 4. What's our height? The perpendicular distance? 9. So our area of this triangle is 1/2 times 4 times 9. Half of 4 is 2. 2 times 9 is 18. So the area of the whole shape is the area of the rectangle plus the area of the triangle. 24 plus 18 is
24 plus 18, 42.
42 centimeters squared, because the area is like tiling the floor. Tiles are in squares. All right, for our perimeter, what's this side? 10 plus 20 plus
4. No, wait, 1.
1 plus.
1.
Okay, so 10, 20, 22, 24, plus 12,
36.
plus 12 more,
48.
48.
What's that? Wait, I don't see the shore.
Okay?
Oh, never mind.
This shape, here, Belle, is a square with 4 semicircles around it. When you find the area of 4 semicircles, or find the area of 1 semicircle, multiply it by 4, or find the area of 2 whole circles, add that to the area of the square. If you had extra time and you want to find the perimeter, you're only finding the perimeter of the outside, not of that inside square, just what's in orange. So go ahead and try this one on your own. Find the area. If you are bored and have extra time, we will find the perimeter as well.
I thought there's no perimeter around it.
The perimeter of a circle is called the circumference.
Oh, yeah.
So we can still find the perimeter using what we know about circumference.
Are we gonna have another quiz or a test?
You have a test next week. I don't remember.
Oh. 20. Oh, I know how to do this. Am I supposed now? 3 squared plus that. 1, 3, 4. Oh shoot, is that an answer? No way!
This is the area of light travel. You have 2 circles and everything. That's the area.
That's 9.
What you asked is
Wait, no. 3 squared plus 9 times 3 20. Oh, yeah.
Alright, raise your hand if you have an answer for the area.
Oh, shoot, wait. Yeah, I have an answer for the area.
Alright, Spencer.
Alright, my answer was 137.
Abby, what'd you get?
92.
Alright, 92.52 is the area. Did anyone try the perimeter? Audrey, what'd you get for the perimeter?
oh, I'm gonna get candy.
Alright, check your answers.
How do we do it?
If there is something you don't understand, let me know. You will have one like this on your test with either a square in the middle or an equilateral triangle.
I got 72 instead of 92.
I'd have to look at your work. Here, this is what I did. I found the area of this square. 6 times 6 is 36. The area of the square is 36. You should have that written somewhere on your paper. Then I find the area of this semicircle. If the whole side is 6, your radius is 3. To find the area of the semicircle, you do pi r squared, 3.14 times 3 squared. Take this answer and divide by 2. This semicircle is 14.13. There are 1, 2, 3, 4 semicircles there. So I took 14.13 and I multiplied it by 4. You could have had 36 plus 2 times 28.26, and that's just that you found the area of one circle and multiplied it by 2 because there's 2 equal circles there. Okay?
Sure.
You have a question? You sure?
Wait, so like I understand like how you find the area of a semicircle. But like so like where it says the 4 times plus 14 like what does that mean?
This semicircle has this area, right? Okay, that's the area of a semicircle.
Oh,
1, 2, 3, 4. There are 4 semicircles. They have equal areas, so you have to multiply it by 4. You could have done 36 plus 14.13 plus 14.13 plus 14.13 plus 14.13. That's fine. Multiplication is repeated addition, so that's a faster way of solving it, to just multiply by 4. Are there other questions?
No, this is pretty easy. All
right. The back is very, very similar to the front, but this time we have a piece removed instead of a piece being added. So to find the area of a shaded region, you must find the area of the whole figure and then subtract the area of the unshaded region. So if I'm looking for this gray shaded region, there is a rectangle here with a triangle that has been removed. So we find the area of the rectangle, we subtract out the area of the triangle. So my whole figure, the area is the length times the width, so 12 times 4. That's the whole shape. The area of this triangle is 1/2 base times height. My base is 9. My height is right here. This is the perpendicular distance. We can transfer it over. My height is 4. So the area is 18. The whole shape is 48. We remove that triangle, which is 18, so the shaded region is 30.
Wait, what?
You guys try the two on the bottom. One is a rectangle with a circle removed. You have to find the diameter and then use that to find the radius. And then skip this one because you can't assume that those triangles are equilateral or isosceles. You did this one?
Miss McNair, seriously? There's more than needed.
Then you haven't solved all the problems.
No, yeah, I haven't solved all of them. Like, there's 1, 2. There's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Unless there's oh, wait, never mind. Oh, I forgot to mark 18. Is there anything else? I'm gonna get the area.
Yeah, don't do that one.
Oh, so we're supposed to do that last one? Okay.
Area of shaded region. Can you leave me alone?
Can we have like 1 more second? I really need just 1 more second.
So, when you are doing this classwork, it is very, very important, just like in the angles, that you're doing your work by yourself. Because it's very visual. If you're watching someone do the problem and copying down their answer, you're not going to get that visual piece with it, so you're not going to understand how to look at these shapes. Solving the problems is not hard. You're using formulas and plugging in numbers. The hard part is knowing where to identify those numbers. So like this one, I bet I get a lot of questions on what is the radius, because people don't know how to find that because they're not visually looking at it, or they don't see it directly written on the circle. I get a lot of questions about what's the base or height on a triangle. So you got to make sure that you are looking at the shapes and you can identify these different pieces. Does someone want to share their area? Spencer?
Could I say what I did?
You can tell me what your answer is.
Nothing.
Okay. Audrey? Alright, 0.2344 centimeters squared. So, if we look at this shape, we see a rectangle there, and that white part is a circle, so it has been taken out. The area of a rectangle is just 0.9 times 0.4, which is 0.36. I think everyone should have got that. But the area of the circle is harder to find because you don't see any dimensions here. But since it goes from the top to the bottom of a rectangle, we know the side of the rectangle is the diameter. If you know what the diameter is, then you can find the radius, which is 0.2. The area of the circle is pi r squared. 3.14 times 0.2 squared, which is 0.1256. When you subtract those, the rectangle, which is 0.36, minus the circle, which is 0.1256, you should get 0.2344 centimeters squared. Nicholas? I noticed that my circle touches both sides of the rectangle. It goes from the top of the rectangle all the way to the bottom. So from the top to the bottom, that side is 0.4 centimeters. That's the diameter. Spencer. Okay, good job. Question? Oh, I didn't solve that one myself. The reason I didn't solve this is because it's not, like, these are both 25, and it's not obvious that it's like that. But I can solve it quickly and let you know if you got it right. It looks obvious, but it's not written down. It doesn't say this is 25. You could have found that one's 25, but you couldn't figure out that one's 25.
The 50 up to the other plastic part, so that's 25.
Yeah, but you don't know that these are parallel. Like this could look like this. Like you don't know for a fact that they're the same. Okay, in class today, this composite figures as a trail. It looks like this. There are Pokemon up on the windows. It's not on Blackboard yet because I haven't had a chance to put it up there.